the microphone's working? I think so. Good evening! How are you all doing? I'm just checking everything is alright. Seems alright. How are you all doing today? For some reason, it feels like ages that we did a live stream, but can't have been. Like, only a few weeks. Maybe 2? I don't know. Draadstal was eerder. Yes, Draadstal was the first. Let's lower that music a bit. There, that should be okay. Maybe a little bit more. Music a bit loud. Yeah, don't worry. I still have to turn it down. So, what are you all drinking tonight? Because I've got something special. Well, I guess. I don't know. I haven't had it before. I actually had a drink with the same flavor earlier today and I didn't like it. So, hopefully this one's better. Apologies to anyone trying to get Diff Solo from Dr. Z's. I grabbed the last couple. Well, you should have more on its way on the C shipment that's been on its way to him for a few weeks now. I think it should arrive any moment now. Let's hope in the next week or so, but fingers crossed. Hertog Jan, says Perry. Nice. Perry has a nice beer. So I have... Oh, this is a bit blown out, but maybe the sun isn't down yet, so it'll probably correct itself. I've got something special. A friend of mine bought this, and I haven't tasted it yet. So this is Fanta without sugar, ohne Zucker. Mango. Mit exotisch Mango-Geschmack. Oh. Meerweek. Wieder befühlbar. Okay, my German isn't great. Sorry. So, yeah, we're gonna give this a try. Oh, wait. It's become unmixed. It probably was in my fridge for too long. But it's still good. It's 0524. That's exactly the month we have. So I guess I should, I don't know, mix it a little bit. Because, yeah. It's probably been laying... Yeah, that's it. It's been laying like this on one side for, well, for a few months now, I think. So let's just roll that here, remixing my drink. Oh, Papa Bros is drinking Diff-Power. Ooh. Well, let's hope the current prototype today goes well and it does what I designed it to do, and that actually also then solves my problems, and then we can proceed to the next step again. So is this actually working? A little bit. Yeah. It's getting less. Water for a change, says James Derrick. Oh. Could you talk like Arnold Schwarzenegger? No, I couldn't really. I don't think so. What does he say again? Get to the chopper! I don't know. Is it smoking? What is smoking? I'm not smoking. I don't smoke. I sniff in like flux fumes, but that's about it. Good evening, Johnny Bergdahl. No, the Fanta isn't smoking. I'm just remixing it. I don't think there's any prick, how do you call that? Carbon dioxide, fizz on here, so I don't think me mixing it matters. We'll see. If it's not smoking, it's working. Oh, that's a good one. Dance Party remix. Oh, I know what I did wrong. There, that's better. Oh, Philip is here. Mixing Fanta. You don't need to add power. No. This is manual mixing. So let's see if those stains are gone. I think think so. I don't see them anymore. No, no more stains. Good. Yep. That means my Fanta is now properly mixed. So let's finish this drink. Still drinking with a straw because my teeth are still bothering me. If it keeps up until next week, I'm going back to the dentist. Oh, maybe it is fizzy. Okay, a little bit of fizz. Oh, well, you can see the fizz. Okay. So maybe it was fizzy and now it's not anymore. We don't know. We'll never know. Well, it's still pretty fizzy. Well, it still has some fizz in it. That's not bad. I hate these new... The thingy needs to stay on the cap. Bottle caps. Oh, so annoying. Okay. Well, before I had another drink from another vendor, also in mango flavor, and I was like, ugh. So, but I normally like mango, so I don't know why. So let's try this one. Who knows? We'll see. I don't know. We'll drink more of that later. I don't know if I like it or not. There's more of an orange flavor, I guess. We'll see. We'll see. Right. So, oh, it's not time yet. We're not allowed to talk about what we're going to do today. We're still in the pre-show, and I'm not seeing my numbers there. No Kitty today. Well, maybe he'll show up later. Who knows? He's in the living room. I saw him. At some point, he often comes to check when I'm here. If he can get some head scratches. Or in worst case, maybe some kitty snacks out of it. You can share secrets for 5 minutes. Well, maybe I could share this. Hold on. Let me prepare this a little bit. Where is it? What? They changed the menus. And let's see if this scene still works. Where is... Oh, look at that. So, I've been hard at work. No, wait. There. I've been hard at work at the analog section, and then mainly here in the Quinled AN Penta lineup. And there's some articles here now, and some pre-assembled boards that are coming with some interesting features and what sets them apart, basically. But if you go to the AN Penta Mini section now, you'll see, oh, look at that, there's now photos. And there is a lot of articles that you can go to. So like there is a specification article with some nice photos and features, power dimming PWM. It's like, oh, it's the 48 volt compatible and has built-in fuses and it has MOSFET drivers and it has easy expandability. It comes in a nice housing. Some more nice photos of the product. And then we have a different capabilities article now, which shows you how you can do higher bit depth dimming if you're on ESP Home versus WLED, and a little bit about the fuses and the channels that are on there. And then there's a power handling article now, which talks about power handling, because we have fuses and we have MOSFETs, and both have their own power limit, so you kind of need to divide the wires over those ports. So I make a example calculation for that, and here on the negative side, and why can't you combine things, and what does it matter if we run extra high PWM frequency, etc, etc. And then, hey, this controller feels a little bit warm to the touch, which is correct. And then I kind of explain why that is, and we added some speed holes to the end, the back and the front plates to get the heat out of the enclosure, and that seems to work well. And yeah, see, speed holes. So there's a lot of articles live now. You can see all the terminals and what kind of antenna I use, description of what all comes with it. I wrote an article about I2C and Stemma QT port that's on the controller expansion, because that will be on future controllers too. So we have the connector and how it's wired and which cables you can get for it, and you can get Stemma QT to female DuPont cables, so you can easily connect stuff that doesn't have a Stemma QT connector. They're only like $1 or so for 10, I don't know. And you can get a screen or a temperature and humidity sensor or a port expansion if you need more buttons or something like that. Or if you want a potentiometer, you can connect an ADC over I2C, just hook it up and configure it. And, well, there's now a wiring guide on how to wire stuff up. And, oh yeah, there's a guide on programming for if you brick the ESP, basically. It'll stay rebooting on the serial port, which will keep disappearing in Windows. How to fix that, and there's multiple methods for that. And, well, I'm still writing some articles, and Paolo from the Discord CJ is also writing an article on configuration things. And, well, the AN Penti Mini is getting closer to release. There's now lots of information available, and I'm hoping to release that maybe next week. But if I can't, there's still some reasons we might not be able to do next week, then it'll be the week after that. So, yeah, getting very close. So, yeah, you know, as far as secrets go, I guess that's a secret. It's not really a secret because it's publicly online, but... H2C03, okay. The Quinn HQ search going. We've evaluated lots of options, and most of them are we're still waiting on one plot of land that's fairly close by that we hope will go on sale or become for sale relatively soon, because that will be an ideal spot. But we're evaluating multiple options still. Still haven't found anything yet, so... Hey there, Nigel Young. Welcome. Yes, speed holes. Jelle Peters asks, how's the Quinn Energy project going? Well, as Philip asked, I'm looking at moving, and that's kind of why the project grinded to a halt. Because I don't really want to make all the changes here and build it into the house if I'm just going to move anyway, right? Then I'd rather take all the stuff along and build it in the new house. So that's why I kind of stranded, and we're focusing on other things right now. But who knows, maybe in the future I'll pick it up again. Koolzuur, yes. Okay, Jacco is not spending all his money on the AliExpress sale that is going live in a few hours, just a little bit of it. So he can buy AN Pentas. AN Penta Minis, actually. Oh, the stream is officially started. I was rambling too much. Too much fans at the door. Yes, that's exactly the reason why we're moving. No. Okay, so today we're going to take a look at... No address there. Take a look at this guy. So as you could see, the previous prototype of the receiver board on the AN Pentium, no, not the AN Pentium, on the power-diff system didn't fix the issue where it would turn on the power before we kind of wanted to turn on the power on the receiver board. So, we discussed a little bit about that on the stream, and we continued that on the Discord server. So now I've implemented basically a switch on the sender board so that the sender basically doesn't send out power until it detects that a receiver board is connected. And once that is connected, it will wait a few seconds and then send out the positive side. So negative or ground will always be there, but positive won't be activated until, it knows that there's a receiver board there, basically. And, well, that is this monstrosity. Oh, other way around. Some of the parts are still the same. Some of the parts are new or changed or different. This is quite close together. It's a bit tightly packed board, but I'll try and make it work. We'll see. Yeah, this is still 4-layer, no problem. Yeah, this would be very hard on 2 layers. Yeah. I believe the bottom layer is just ground, so there's 2 ground layers in there. But yeah. So that's what we're going to build today, and then we're going to test it. And, well, let's hope the timer circuit works. It kind of worked on the other one, so in theory I transposed that on here, so it should work on here. And then let's hope that solves our problem, because I kind of had to cannibalize one of the ground lines. So now we have 3 positive lines and 2 ground lines. So I'm going to have to test and see what kind of issues that might cause in regards to power delivery or not. In theory, the power lines will still be balanced. There will just be a little bit less ground, but should be okay, I think. And we won't have to downgrade the power capacity that much. And, yeah. What is the OR mark over here? Well, there's going to be a USB-C plug over here or a terminal for 5 volt out, because you're feeding this board with 55 volt. But you shouldn't use both at the same time, because there's no protection in between. They're just linked together. So that's why it's an OR. I'll make this bigger in a minute. Hold on. So first we need to take a look at our stencil. No address here, I hope. Too late anyway. Yep. How is the music now? Is it okay? Well, the silk screen is actually arrows. Hold on, I'll show you. Come on. There we go. Okay. We need the stencil, but if you take a look at the silk screen, these are arrows, but they might not be pronounced enough. Let's take a look at that. Okay. We need our board. Does that actually fit? Wow. No, okay. It's close, but it's not. It doesn't really fit. Still need to adjust it. This one. Okay, let's jam it in there. And then we stick it down. I can look at improving that silk screen. I mean, these are still prototypes, so. Okay. Let's see. Stencil. Now we need to line that up carefully. there. I think that's it. So let's stick this down. No, don't bulge. Okay, I'll stick all sides down. Normally I don't do that, but... The stencil is sticking up for some reason. Don't like that. Do it again. Screws under one? What? Yeah, that's better. A little bit. Okay. Let's see if we still have some paste and tools and... We got multiple bottles of paste. We got lots of bottles of paste. Okay. It's probably old, older, and old. Let's see. 220504. 211217. 230521. This is the newest one. Good. We'll use that for today because I want this. Don't want to mess around. A Windows logo. Oh, you mean the little heart there? It's our little heart. It comes to join our stream to... Oh no, look at the paste. It's very dry. I'll try and mix it, see if it becomes a bit more viscous, but... I think it's still okay, but it's not as gooey as I'd like it. Let me check one of the other pots. See, this one's a lot more gooey. See that? I wonder what happened to the other one. Okay, we'll use that. This one's just too rough. Might need to, yeah, it's also, chunky. Might need to add some flux to it. We'll look at that some other time. Okay, well, let's use this gooey stuff. That looks better. Just add butter? What? Don't add butter to your paste. Okay, where's our... So now we need to bowl it up a little bit. There, and let's go. A little bit over here. Let's just do it twice. I think that should be good. Let's check it. Yep, that looks good to me. Seems to have hit all pads. Good. Even over here, I think, yeah. Yep. Okay. Let's get some tweezers. Oh, you ran out of flux. Damn it. It's okay. I have some. Scraping it off the scraper. Maybe that other tub wasn't closed properly. I'm not sure. Okay. Okay, let's do a little bit of cleanup. Oh, I don't have tissue. Oh no, I've run out of tissues. Okay, that is fine. Let's put the stencil back, because I might want to build more, but not today. Put it over here. Whatever. Okay. You go over there. Right, so let's get this positioned so that you guys can see. Mouse. I think it's this one. We just apply some digital zoom, we'll call it. There, that should do it. Is it in a good spot for me? A little bit closer. Can I now move the screen? Oh, look at that. Perfect. Okay. And then we need an IBOM file. No, not over here. Stupid window, come on. And let's see, browser. Well, at least you can see what component I would be working on. It's not great. Why is everything green? Okay, that's better. But now I can't see my video chat. I'm gonna put it in on another window. Let's do that. Okay, make the text a little bit bigger. Almost there. Sorry. Oh, there we go. That'll work. There. Now you guys can see, I can see, everyone's happy. So, I just messed up the order. What? Go away. I like it in the default order, but I never know how to restore that. I guess I'll just, I don't know. Ah, stupid. What is the default order? Let me open it again. C7. Oh, okay. It's now in the default order. Perfect. Just throw everything on there. It'll auto-fix itself. It's not that magic. It's a little bit magic, but not that much. Okay. What? What's going on here? This makes no sense. 2.2 UF, 2.2 UF, 16 volt. Oh, can't see. 16 volt. 0603, 0603. These are exactly the same, but they're split out. Why are they split? What's going on? Oh no. Okay, that's what this button does then, I guess. Sure. Later, Johnny. We'll have it built by the time you get back. Okay. Good enough, good enough. I know it's a bit hard to see where the components go now, but I can maybe squeeze a little bit. There. Okay. Let's just get started, because otherwise we'll be here for hours. We will be here for hours. Okay. Capacitor. Oh god, I redid everything recently. Okay. 0603. Yes. Let's make sure I have enough cable. Oh no, everything is on top of my cable. There. You need the column footprint? No, I don't actually. Oh, I can of course turn that off. Oh, very smart. Yes. Perfect. Thank you. And now I can probably make this a bit. Oh, no. Okay. Excellent. Good. So, 2.2 16 volt. 4.7. 2.2 50 volts, 2.2 60 volts, and we need 4. It's been a while since I did this. I need to get into the flow. Okay, well these don't have polarity. I'm gonna have to be really careful later on, because some of these are near some big ports. In all my years, I still haven't figured out if it's better to do the small parts first or the big parts. I usually do the small parts first, though. So let's see if we have other 0603s. We have a 10-0603. 16 volts, do we have that? We got a 25 volt, that's fine. Well, it's not so much about the soldering part, but more about the placement part. Low to high, yeah. So then it's still probably the small components to the big components. So let's see. Oh, here's an 0603. 100 NF. We've got that. Oh, 100 volt. Uh-oh. Almost messed up. 50 volts. 100 volt. Okay, so we need the 100 volt one. It wouldn't have been good if we put a 50 volt one there and then put 55 volts on it. Probably wouldn't have liked that. This guy is right in the middle of everything. It would have been good for you guys, yeah, maybe. Let's see, 0603. No, got all 0603s. Okay, let's go to 0402s. Capacitors. Where R-type box. Truck bomb, resistor, capacitor 0402. Let's see, we need, of course, we need 100 NF, 50 volts, sure. Yep, 60 volts. Okay. 100 amps for 5 meter? What? 1 UF. 10 volts? 16 volts. Okay. Then we need some 2.2. Oh no, that's not 0402. Can't be 0402. Oh, we're done with 0402 caps. Nice. Okay. So then let's go to 1206s. And 2.2s. See, here's something weird. 2.2 UF 100 volt 1206, 2.2 100 volt 1206. Description might be slightly different. There's an extra space there or something. But at least now I know I need 5. 1, 2, 3, 4, 5. Well, these are easy. Oh, I got 6. Oops. That's good. Are these optional? These are optional. I'm going to place 1. I don't actually... Well, I'm going to place 0. These should have been do not place. So maybe the do not places didn't land. I don't know. Because that's something, these are pads I want to experiment with and not use right now. So, bye-bye. Okay, so let's say we place those. Then we need a 22 UF. And we got a 16 volt one. We have a 25 volt one, that's fine. Oh wait, this is 0805. Wrong size, should have been in a different section. There. So 10, 22. Hey there, Andy. We still know you, don't worry. How's the house going? So this is a big one. That's a big one. That's a big... Oh. Damn it! We still forgot an 0402. Okay. Slow but progress every day. Yeah, that's how it goes. Until you're just done with it for a while, and then you're like, I'll pick it up later. And then yeah, either you do or you don't. I'll check the effect in a minute there. I believe it's juggles. $100, 22, 33 goes between those. Okay, let's see where this tiny little bugger goes. There. Let me check on the effect there real quick. Yes, we're on juggles. It's very low speed with a lot of balls, and then separated for each bar, basically. So a segment for each bar. Okay. So now these are okay. Well, we can still do this one, the 1210 4.7. I actually need to see what box that's in. Probably would be this one. Oh yeah, here it is. We like irrelevant questions. It's fine. Okay. So this one's really big. So these are 1206. This one over here, for instance. Okay, don't mess with it. And this one's a 1210, so it's actually wider, but the same length. No, we didn't do that. Okay. So now we go to resistors, and that's a lot of 0402 work. Resistors, 0402, 30K, 50K. Okay, I need to have this box here. Let's see, 30K, huh? 15, 16, 20. This one's wrong. Shouldn't be in there. Wait, we don't have a 30K? 28K? 20K? Oh, I didn't order 30Ks, huh? Now, for these are for the LEDs over here. It doesn't have to be exactly 30K. Something around that is fine. So, let's see, we've got 28 or 50. 53, 56. Yeah, let's do 28. That's close enough. Or we can do 31. No, this is 31.6, not K, without a K. That would have blown up the resistors. 1, 2, 3. Okay. So the resistors go on the left. There. I'll align those with the microscope later. So now we need some 50Ks. I don't have 50Ks. I have 51Ks. Why don't I have all these values? Am I missing something? Doesn't matter if those are... I think I chose 50K arbitrarily. I'm going to check in the circuit real quick. What circuit those are part of. Okay, so the 51K needs to be 51. Or no, we need the 50Ks. Oh, it changed that. It changed that. This is wrong. Okay, what? No, that's right. Okay, never mind. I'm confused. R17. Oh, there it is. Jesus. Okay, so here, okay. Here, okay. Right, okay. For all of those, it's fine to use a different value. So we're not using 50, but 51K. They're just pull-ups and pull-downs, so... Yeah, there was a giant fire in Os. We could smell it over here. Wasn't too bad, but... Oh, wait, there's a fire right now? Again? There was a huge fire like a few weeks ago. I haven't been outside, so I haven't smelled anything yet. Okay, so these will be 51Ks. I need to note that down. So let me make some notes. Oh god, where's my mouse? This monitor is being blocked by some light bars. Okay. Hold on. 1 second, please. Okay, just needed to note that down. So we did these. Yeah, 2 weeks ago. Yeah. That we certainly noticed. Let's do these 56Ks. Okay, those just go there. Okay. 200 should be in here too. Seems I chose some arbitrary numbers for resistors and then never bothered to shop for them. So we have our little book here. That should have a 200 in there. Yes, 200. So I've got a little little card here with. Always good to have one of those little books. Because you're soldering and then you're like, oh, I need this value. And you can't find it, or you didn't think to order it. That's mostly my issue. Yeah, 200K. There. Not sure I got the right size right now, but we'll see. These feel a bit big for the pad, but we'll make it work. We'll make it work. Okay. Now I need to check something. What's going on? There's this guy. It says we've placed it, but we clearly haven't. But I can click on this one. I can click on this one. I can click on this one. But I can't click on this one. Oh wait, these are then likely do not place pads? Is that it? Let me check in the design file again. Yeah, okay. So that's a 10 NF, okay, yeah, and this is a 0 ohm, okay. Those are indeed do not place, I believe. Properties. Do not populate. Okay. Okay, good. That's good. But then why are they even there? Oh, okay, annoying. Are you using cork thing for hot pans? What? Yes. They are great soldering surfaces. Oh, at least in my opinion. Let's see, 51K. I should have over here. No, I already did. Didn't I do already 51K? Oh no, this is a different one, and this is also 06 or 03. Okay, we'll skip that. 12. Okay, so we need to go to the lower values 0402. That's fine. So I have an X1 carbon with an AMS sout. I bought it about 6 months ago, and I've done some printing with it. And generally, I really like it. I'm using it to actually print now instead of tinkering with my printer. I mean, I know it's the cliche story, but that is actually how it works. Things just come out, and they're good. So yeah. $15.8K. Oh, it's also an AO603. Never mind. Let's see, do we have any 0402s left? Yes, 10Ks. Need to make a note. Let's see, 1K. Okay. 1K goes over here. So after this we'll take a look at the LEDs. Let's first do the 0603 resistors. Low, I think. Yeah, let's start with low. Let's do the 120. No, the 120 doesn't go over there. The 120 goes over here, but I didn't have that one selected. There. 120. And then we need 51 and 15. This box goes to 5.1. So we need another box. Oh, I moved it. Let's see, 15.8. That's a very specific value. We hope we have that. Maybe, maybe not. Don't think I have that actually. I know why. So we're gonna hope our little book can help us again. Is this an 0402 book? Or is this in... No, we need 0603. Okay. Let's see. We need 51. Here. It's not 51.8 though, but the next one is 56. So we'll have to make do. And this will affect the output of the voltage regulator, I think. I'm not quite sure if it'll lower it or raise it. But we'll have to see. We might see smoke just yet. Okay. 51, I think I saw. Okay. So now let's do some LEDs. Here. Where would I have my S&D LEDs? Oh, this is not sorted. Okay. Oh, maybe it is. I didn't relabel these back, so now I have no idea what's in here. Orange. Well, I guess we can use these. Let's turn on the multimeter. There's a little baggie here that says green, so should be good. I'm not sure these are the right size, but again, we'll make them fit. These feel a little bit too big for 0402. Yeah, they're too big, damn it. Okay, can't use those. It's not gonna fit. I should have some 0402 green LEDs somewhere, I think. That was the next bag. Okay. See, this is green 0402, perfect. Now let's see if I can, nope, still need to move it a little bit. Okay. Multimeter. Because I never know which orientation these buggers have. And, I believe ground is on the bottom here. I'm gonna check that. Check it. Otherwise you'll regret it. Stop giving me useless pop-ups. Ah, see? I would have regretted it. Ground is not at the bottom. Ground is at the top. So, we take, we go to continuity mode. And we take our probes. Let's turn it around. Like so. Yes. So this one is now in the correct orientation, and that has the green thingy on the bottom. So this one should light up. Yeah. And this one should too. Yep. Okay. Noise. Now I need to place them without flipping them again, so I'm going to do that real quick. Oh wait, damn it, I'm making a mistake. I just said ground wasn't on the bottom, and you guys are allowing me to place them with ground on the bottom. Okay, I can't see. I think that's okay, but I'm not sure. I tested those already, Jean Francois, and they're also already in the real world power sheets, etc. I like them. So right, so LED orange done. LED green done. LED orange. Yeah, sorry. I'll fix it again. There you go. Now let's do an orange LED. I think that's all the LEDs. Yes. Let's do some diodes. We're already doing diodes, but different diodes. No, why? Now. Okay, we need some very specific diodes. We need this later. Oh wait, this is my wrong diodes box. This is for ESD and Zener protection diodes. We need a Zener though, so let's put that on there. There. Okay, this box can go. That's not established there. Diodes. SMD diode other sizes. No, SMD diode SOT 123. I think. Let's see. Four. Ooh. Okay. So, are you guys just here to see if it'll blow up later? What's that? It says 15.8, not 51. Which one are you referring to there, little Papa John? double checking if I got the right dowels. I think so, but they look different than I remember. Yeah, should be good. Ah, okay, yeah. Working on the house is tough. I get that. I think most of the small components should be done now, though. Yeah, it looks like it. So let's do the BSS 123. Okay, that is a MOSFET. I think it's an N channel. Okay, then we need 2 P-channel MOSFETs. I'm building a giant tower just off screen. And we need an, let's see, this one.
Think I need an exorcist right now. Oh, hear your voice, but you are not around. Oh, visions of your face are breaking down. Left me headed for the coast.
There. Oh, I can't get it to turn over correctly. Okay. It's a tight fit, but it fits. Okay, let's do some PTCs because we have a lot of those. SMD diode other size? No. PTC SMD. Right. I think that's this one. That's easy. Sorry about that. Oh, wait. Yeah, we can reuse one. I desoldered these from another board, but they should be good. So this one just goes over here. It's a giant one though. Okay, and then we need some 12 APs. 20 APs. Okay. Let's see, we need a 1206 500. Oh, but that's not 60 volts. We need this one. 200 milliamps. 300. 200. Lots of LEDs, that's good. I didn't read the rest of the conversation. I just got the most important part. During design, I was afraid that these might be a little bit too close to the edge, but looking at it, I think it'll be okay. So that is noise. Let's drink a little bit more of my mango. Oh, now I taste the mango. All Oxmer 24 volt 38.4 watt CCT noise. I recently glued those behind my my TV actually. I'll do a video about that at some point, or at least show it in a video, but it's not that interesting. That is Fanta Mango, yes. Here, look. It's even in German. Ohne Zucker. Mit exotischem Mango-Geschmack. Mehrweg wieder befühlbar. Okay. I think your German is better than mine, Andy. Yeah, a friend of mine brought it. Let's see. 16 volt, 500 milliamp. 1206. You love Fanta Mango. Oh, okay. I'm still getting used to it. I'm not sure yet. Oh, this is an upgrade we forgot. Uh-oh. On the previous board, we actually blew this fuse because 55 volt made it back into the sender where it shouldn't go. Now I put a diode there, but I didn't upgrade the voltage for the fuse. Let me add that to my notes. 16V 500 milliamp fuse should be 60 volt rated at least. There. Okay, well, anyway, this is it for now. We'll see if it blows again. Okay, mounting holes we don't need to do. Okay, now we're getting to the real components. Let's see, buck converter, buck boost converter box. XL7015. Okay, good. This box is done. I guess that's the serial chip.
They talk about another kind of work.
Okay, let's do the RS485 chip. Oh, I need to order more. I've been blowing too much of them. Okay. There. Now we need this guy. I'm not sure where this guy is. We'll see. Logic buffers. Serial chips.
They talk about another kind of work.
Nope, not in this box. Okay. Which box would that be? Maybe this little still needs to be sorted box. It is! I knew it! I knew it! We're starting to get there, or at least for the SMD component. Okay, need to find pin 1. Okay, that's pretty easy. Okay. So now I think it's just a few big parts and then we can already do the SMD. So we need an inductor and some caps. Okay. Let's do the inductor. That's not the right one. Interesting. $33, $33, $47, $47. I need 100. Is there a second box of inductors? Did I label it wrong? We'll need these in a minute. Where's my inductors? I see the box. Oh, can't reach the box. Okay, here it is. Inductors 100 UH plus. Breda, de gekste, ja. Why is that? Did I line that up right? I think so, but let's check. Yes. Okay. So, done with the inductors. Now we need some caps. We need a 100 UF and a 33 UF. Okay. Little bit de gekste, okay. But Eindhoven is de gekste, exactly. I know Eindhoven has de gekste. I don't know. Ooh, this will be a tight fit. Do you see that? Let's see, 33. 10. 33. There's a smaller 33. I do. 100 volts. Yes. Okay. Well, yeah, without the heat, we can't really solder it, can we? So let's try and place this without knocking things over. There. Oh, that's not too bad. Yeah, that's fine. A cold soldering iron. I don't know, man. That's lead to all kinds of sticky situations. There. Okay. No. This is the high voltage box. Now we go to the low voltage box. And we need a 135 volt. 135 volt. there. Then we need this one, but that's a through hole. I think, looking at the picture, we have all SMD components in place. But let's inspect the board real quick. So we have some big empty pads up there, over here. That's fine. These are supposed to be empty too. That's fine. Okay, and the rest is populated except for the USB. We'll do that real quick and then we'll put it under the microscope to see what we need to fix. Let's see, various connectors. I'll need this later. No, we'll celebrate when it works. Oh, I was looking at the number of the stream, and this is the 96th stream. What should we do for the 100th stream? Can't even pronounce it. Okay, let's get the microscope out. Hey there, Medved. Yeah, we haven't done any smoke yet. We should do magic smoke for the 100th stream. Okay. That sounds reasonable. So, we have a microscope. And we need some 12 volts. There. Is it this one? No. Is it this one? Yes. Okay. So let's start the microscope. Yeah. Okay. And let's go to microscope vision. Right. Okay, I'm gonna close the bomb. I don't think we need that anymore. So let's start at the top. Okay, this microscope is a bit skewed right now. There. Top left. There. Those are fine. Those are fine. That's fine. Here it's all kind of wonky. Okay, I need to turn this a little bit because otherwise I can't reach it. Okay, that should do. Here's our 2 big resistor. I think that'll work. Oh wow, okay. Okay. So let's see, this is all fine. almost too much. That should be fine. Yeah, this became a bit of a mess. Okay. Oh wow, okay. No, don't go there. Well, I walked it around a bit, but now it's in place. Okay. USB looks good. There's enough paste on there. That'll fix itself. Yeah, I don't see any obvious issues right now. Do you guys see anything obviously wrong? Hold on just a second. No smoke. That is absolutely the issue. I hope all of my hardware has that issue. No smoke. Okay, then let's get the hot plate. And I need to see how I can do this. Nothing on screen? Oh, okay, nothing wrong on screen. Okay, microphone, go away. Let's deactivate this one. And let's see if I can put this here. Oh wait, no, I'm going to put it here. No. Everything so you guys can see. I need to hook it up to power. Do I have an AC lead here? Don't. No, wait, maybe. I do. Now I need to make sure I don't touch this. Hold on. It's always interesting is that if this thing is going to blow the breaker. It didn't. Nice. Oh, it's not powered on. Nope. No blown breakers yet. Cool. Okay, let's turn it on. And let's get it on there. Get it on there. So let's try and get this thing under the camera. There. Okay, it's now at 30 degrees and it's heating up. So let's, yeah, drink some more mango. Hey? Go for a kiddie stream at 100, maybe. Or a new WLED in-depth review and effects stream. Oh, okay. We could just go through all of the effects. This is only the second stream. I feel bad about missing the 94 earlier ones. That's okay. GS Mevo, you're here now, so... Maybe a giveaway, sure. I was thinking about that. Could be cool. Melt some wires. Maybe we should melt some wires while doing random WLED effects. Quinled smoke machine, what? The Mango Rubicon. I don't know about that. Really nice fizzy drink. Okay. We're at 94 degrees. Get high off of molten wire. No, I just start coughing. We've done that before. I should open a window, huh? Hold on. Oh. Oh, yeah, it's starting to smoke. We're at 128. Now stuff should start happening. Yeah, you can see the PTC there. Oh, we have smoke, that for sure. I guess on this view you can see it better. Yeah, see all the smoke? Okay, I see one that we need to fix over here. There. I'm amazed these LEDs actually did it correctly. I'm gonna take my magnifying glass and look at it for a little bit. Yeah, I'm gonna poke these LEDs a little bit. Okay. Those are all good. Okay. Under the heart. Okay, now in real life that looks fine. This one looks okay. Looks good to me. How about you guys? Later, Philip. Thanks for being here. We'll do a quick check on the microscope, but you know, having to reflow it again, rather not. Okay, let's take the board off. There. And we can put the heat plate to the side without the cable touching it. We can turn on the microscope. So let's take a close inspection. That looks great. Sure, that's fine. Let's see if those are both the right way around. I think so. Let's try and get the light on there differently. Okay. Okay, that's all good. Sure, that's fine. Even the big resistors that shouldn't go there look fine. This guy also looks like it's soldered on exactly right. Because those three should join together. Then you have one leg that's separated. And then it outputs on all legs. This also looks great. Yeah, that's fine. Oh, this little resistor could have been better, but I think it's touching, so that's okay. Okay. It's a mess, but it should work. Okay. Okay. Yeah, even the USB-C plug looks okay. Should have tapped that, but didn't. Okay. Yeah, then we can move on from SMD work to through-hole work. You need new solder paste. Yes, that is also my conclusion. But actually, the newer paste I had looked horrible, so we didn't use that. So we used some older paste, but by the evidence of some balling and things like that, that one is also too old. So I need some new paste. That is a good conclusion. I will order some from Mauser or something. We'll see. Okay, so let's turn the microscope off. Don't need that anymore. Okay, don't need this. Okay. There. Okay, excellent. So, what components do we need to do? We have a big capacitor, but that's likely the highest, so let's do that last. We have some screw terminals, RJ45, and a USB, but that's already on there, so I can tick that. But we should flow some solder into the holes there. So let's get the soldering iron out. Und die Fumex connector. Otherwise, I will die. Should solder paste be refrigerated? Some needs to be, but most modern pastes generally don't require it. So, yeah. Okay, let's flow some solder into these holes. Wait, I should turn it on. And that's just to give the USB-C connector some rigidity. Okay, let's see if that crept up. Oh, still hot. Not really. I think it'll be okay though. The USB-C isn't really important for this board, so you know. Okay. Then the next highest will be, I think, the RJ45, but that just snaps on. So it doesn't really matter when we solder that, it just snaps on using and being held in place with these pegs. There. Music got very dramatic, yeah. So we need some two-way or four-way terminals. So let's get those. Oh, I wonder where I put those. Did I move those? Oh, God. I've been reorganizing things and then I always forget where I put them. Well, they're not in here anymore. Oh, I think I know where they are. Okay, okay. Don't worry. Oh, no worries. Okay. They are likely in this box here. Just need to find the right size. This should do it. You can join them nicely, like that, and then you have a 4-pin. Okay, I need to make a note. Jesus. I need a bigger desk. Okay. So let's solder these on. Okay. This is fitting very snugly, so I might need to change that, but it's okay. Okay, those are on fine. Okay. Those are all looking good, I think. Yeah, a little bit much on the ground, but it's okay. So let's do these real quick. Why is that not soldering on? try and fix that a little bit. It's not great. Okay, good enough, I think. Sure, that's okay. Thought I missed some, but those look pretty good there. So, okay, and then we still have a big capacitor, and then we can start testing. Whoa. There's a giant tower now behind me. Hold on. There. A giant tower of component boxes. Okay, let's try and solder this. Okay, that's on pretty straight. Excellent. Okay, I think that's all the components. I'd say so. So I can finally clear off my disk a little bit and then put other stuff on it. Okay, let's move this away. Right. That's good. Oh, you can't see. So first we need power. Let's use our bench power supply. Now that has fork terminals, but we can mangle that in there. That's okay. Well, maybe not do that in real life. This isn't real life. This is a live stream. Medved's hungry. Let me close some stuff off here. Okay. Oh, I don't need this screwdriver. Jesus. I need this one. because the middle two are ground, let's open these up. Come on. That's why I always use Phillips. Open these up. There. Now the middle two are ground, so I'm just gonna fork it like that. You did, Cybucks. There. And this one I'm just gonna jam in here and then screw down. And if I do that tight enough there, it basically won't move. So although this the screw is ground, or the screw header screw, I don't know, whatever, it's ground, this should be okay. Let me close the window. There's bugs. There's bugs. Okay. We don't want bugs because bugs cause things to blow up. Okay, so we still need a data in. Let's use my little package I have on the desk here. But what we're going to do first is boring. We're going to test it first. So let's open up the multimeters. Why are you not working? The multimeter software. And let's see if we can connect the multimeter again. Last time it kind of exploded. So connect. Connect. Oh no. Let me see what IP the multimeter got. $105. Yeah, should be 105. It says it's alive. Okay. Bugs. No. It can screen capture. Okay. But I can't control it to measure. What? Let me try and figure this out for just a second. I really want to show the multimeter on screen. Come on. Why is this not working? Should I mess with the cable? messed with the cable. Let's see if it works now. Okay, killing the software. Okay, I had to remove it and add it again. Stupid software. It's really shitty. Okay. We have... we need to enter secret codes. Yeah? So we have... What? Okay. We have our thermal camera. Well, we need to power on the bench power supply too. And we're just going to power it up without anything connected to see if it explodes. In that regard, let's I'm always very confident in my designs. There. Now we're safe. So, we want 55 volt and let's say 1 amp. That's already 100. No, that's 55 watt. We'll see. Are you guys ready? I'm not. Let me know in the chat if you're ready. Oh, I did drop frames. Did that start happening when I opened the multimeter software, maybe? It seems to have stopped now. Okay, everyone's ready. Good. Well, power. Well, we got an LED. And the current draw is basically nothing. So let's measure the incoming power. Okay, we're getting 55 volts in. That's good. Do we then have 5 volts out? Or about? No. We have 2.5 volts out. What? More bugs. What? Why do we have 2.5 volts out? Let me try and measure. Two and a half volts. Okay. Frame still. Oh yeah, I see it. I don't know what to do about that. Let me check something real quick. It's a little bit warm and not hot. Okay. Let's turn off power and see why we're... I don't know why we're dropping frames though. Audio continues. Frame still dropping. Let me see in my router if something odd is happening. Nope, not really. It must be the network or YouTube. I don't see anything odd going on. I'm at like 15%, 20% CPU usage. And I also don't see any frames missed due to rendering lag or encoding lag. I only see network dropped frames. So I don't think there's too much I can do with that about that. Well, we have a problem here. Because for some reason the buck converter is making 2.5 volts. Let me check my resistor calculations. Need to find those first, hold on. I don't know where I have those. Must have placed a wrong resistor somewhere that is generating the wrong voltage. And I need to think. Starlink. Let me see if I can find it. Yeah, that's a problem. That's an Excel, and I don't have Excel here. I will check that on my computer real quick, and I'll be right back. Don't move. Let me take my phone so I can make a photo of it. Okay. I return. Yeah, both central terminals are ground. So, it should be a 51K and... I already forgot. Well, I guess I can show you here. It should be a 51K and a 15.8. And that should give us 5.28. But I know we used a slightly different value. Did I write that down? Yeah, for 51 I used 50. And for... 15.8 I think I had. So for 51 I used 50. That might have messed with stuff. I need to punch in how that changed the voltages. So, because I do think I used the right one there. Let me check if I have that one. So the 15.8 I think I had. 15. Yeah. 15.8 we had, so that's what I used. But I didn't have a 51. No, I didn't have a 51, so I used a 50, and that might have thrown things off. Hold on, I need to check in that Excel again, see how that changes the calculation. Interesting. That should actually not have changed it that much. I think you added a 51 instead of 21 at the table of components. I think you added a 51 instead of the 15.8. Well, in theory we can test that somewhat. So let's see. Let's go 2-wire resistance, and then I know it's these two over here. Oh, damn it, missed. So this one's 51-ish. This one... Yeah, it's going to be hard to measure that, huh? Where does it end up? Okay, let's try it again. Let's try it in reverse. Yeah, can't really measure that on circuit. Let's try and see if we can read the values. I'll try and use my little magnifying glass first. Aha! I think you're right. I'll take out the microscope so you guys can see too. Okay. So, if we look at those resistors, those are 513 and 513. And they should be, let me open the I-bomb. Well, I'm going to open my KiCad file real quick. .51 on the left and 15.8 on the right. But if I look at this, for somehow I used 2 times 51. But they're different. They're a different kind. So it almost seems like. But in theory, then it should be an easy fix. Because I have a... Whoa, I can't see that. I have a 15.8, sorry. That 15.8 resistor. So we just need to get that on there. Did you look back, Papa John, or how did you find that? And it's actually very plausible, because if I look at the tape... hold on. There's none. There isn't one that I took out. See? This is the first one. It's still in there. Other side is the same. So I never took out a 15.8. Wow, that's a good memory there. Let me just double check something. Yeah. Alright. Now this will be interesting getting that in there. I'm going to disconnect the cables first. Oh, sorry, I must have missed it then. But you're absolutely right. That is not the right resistor. Okay. Now, one of the things I do on prototypes is I use low temperature solder paste. So 138 degrees. Let me find the resistor. There. And it has to be... Yeah, okay. So let's see if I can make this angle work. No. Like this, I could make it work. Okay, so we need the resistor. But I use low temperature solder paste exactly for this reason. These are prototypes that don't go into production. And so I often have to rework or change stuff. But because I use low temp paste, I don't need that high a temperature. Now, there's a problem. This is 0603, not 0402. Let me see if I have an 0603. Resistor high, I think. Let's see if I have a 15.8 here. I don't think so. No, I got a 16.2, 16.5, 16.9, 22, 30. Okay, we're gonna try and bodge an 0402 on there. Because that's the only one I have. Yep. That's what's happening. So we're probably going to melt this little screw terminal here a little bit, but we'll see. Okay, let's go to 200 degrees. We don't need a lot of airspeed. And let's hope... Oh, God. Okay. Let's hope we can get it bodged on there. Need a bit more airspeed and temperature. Okay, it's off. Now to get the little resistor in its place. So I'm just going to make sure it makes contact with this pad. There. Oh, it might actually be making contact with both. Let me check. Hold on. Yeah, I don't know about that. Okay, let's tip it with the iron. At least that one pad is making good contact. So I'll tip it with the iron and then both should make good contact. Oh god, I'm lost. Okay. My wires are a gigantic mess here. But that's why I make it work. My mic still working? Yes. Okay, so let's get a different tip. Because this one's way too big. I'm not sure this tip still works. Let's check it. Yes, okay, so this is a lot finer tip. Can't really see that. That's okay. So let's see. That already does it. Doesn't need much. So that should be a perfectly fine connection, I'd say. One issue is that this this resistor is, I think, 50 volt and not 75. We'll see. We'll see about that. Generally, with a resistor, it matters a little bit less, but you know. Okay, let's remove this. Okay, so let's screw that in again. Oh, sorry. Okay. Be careful, there's a solder ball next to the self. The self? No, there's the one near the inductor, I guess. Okay, got it. And there's some solder balls next to the PTC, but not really worried about those. Okay, think I got the one you mentioned. Okay, so the board's a bit warm now. Yeah, let's wait for it to cool off. I'll do some manual cooling. You know, it really works though. You can still see the imprint on the cork. Okay, let's see. There, that cooled the board down a little bit. This month even, I don't know. Oh, okay, well the month's almost over, so that's true. Okay, let's put it down over there. Okay, voltage test mode. And before I plug it in, I might have made more stupid mistakes. So, the goggles are back. Okay. Let's turn it on. 3, 2, 1, go. The LED is now brighter. That's good news. Let's see over here. 5.31 volts. Perfect. Now that is a bit high. But that's because there's a diode there. And when there is no load on that diode, well, it'll have a high voltage, but once there is load, that voltage should go down. Well, I can't really make anything of these temperature measurements right now because, well, everything's warm. Okay, let's hook up the dig quad here. So we're going to use these output terminals for that, so that we don't need multiple power supplies. Because we're inputting 55 volts, and the quad can't handle 55 volts. So, yeah. And then we have a single little output wire, and we're going to attach that to this terminal over here. Because that's where our data signal is going to come from. Okay. I'll zoom out a little bit more. No. So let's then see if that works. I'm going to put my headphones on again. Oh no. How did I get a loop? What? Okay. Okay, let's go. Okay, it's drawing about 1 watt. And now let's measure the output voltage again. Because I'm thinking it will have gone down, which is the intended thing to happen. Oh, it's actually down to 4.9. Interesting. That's a little bit more drop than I was expecting. Let's see what the voltage regulator is making. Okay, we're still making 5.3, but because of the diode drop, we're now at 4.9. Luckily, especially the newer DIC quads, they really don't care. That is a perfectly acceptable voltage, and on board it'll still make a 5.1 volt data signal because of the circuits that are on there. So that's fine. Now let's put this one in place. So it can go back. Okay. Let's see if anything's getting hot. Well, the RS485 chip is getting a little bit warm. That's normal. And the termination resistor is also getting a little bit warm. That's also normal. But we're talking about 42 degrees. That's like, what is it? 25 ambient. So it's not that much. That's fine. Okay. This wire is annoying. There. Fixed it. Okay, this can go on this side, I guess. So now that we know that works, let's turn this off. Let's set I to 2.5. Okay. And I think we're just going to hook up a receiver board and see what happens. It's not blowing up. That's good. Okay, I need to get my power-diff box. So here's the power-diff box, and we need to get a receiver that doesn't have any logic on there yet, because we're moving the logic back basically. Let's see, this is for a 12 volt output. Do I have a 5 volt one in there? It's 24 volt. There. And this is for a 5 volt, and I think this is one of the newest ones. Yes. Does this already have the... Oh, what's this? Did a spider get in here? I don't know. Let's see. Yeah, this one already has the 3 LEDs. That's good. And I believe I fixed all these, so they're working. I'm not 100% sure, but we'll see. Okay, we need a 5 volt LED strip. So this one, yep. And then we need a little patch cable. But I think I have one over here. Later, Perry. Right before the last test. Oh my. Okay. So, we hook up the LEDs on this side. There. We can put it here. Like so. There's some status LEDs here, so I'm not sure how I'm going to show you that. We'll try and figure that out. And, well, we're just going to use a very short UTP cable. Yes, you have to wait 5 minutes, because this will either work or blow up. So, we're going to hook this up. There. And let's see what happens. I don't know if the RS485 chip on here was working or not. We'll find out. If we see orange, that's good. If not, that's not good. Okay, I'll put my seatbelts on again. Okay. Power. Okay, nothing on this side. That's good. Nothing. Nothing. Oh! Wait, look at that. Okay. That's good. So, if we turn off the power... Yeah, no, these are up to 60 volt in. So, yeah. If we turn off the power and we turn it on again... No, why is it instantly on? That's bad. It just worked fine. Did it only work fine once? Let's try that again. Power off. Disconnect this stupid wire. I don't know. No smoke. I did hear a little tick, which I wonder about. But in theory, when I turn this on, this one should turn on. No, it's not working. No, well, it's working, but not working. This one should turn on, and then only seconds later, this one should turn on. Not immediately. And the first time, it did that. The second time, though, it went on immediately. That's bad. So let's try it again. Power. See, that's bad. That's not what's supposed to happen. The LEDs are coming through correctly, it's just not configured for SK6812. I'll do that real quick. No, I need to see if something is getting warm. Hold on. Okay, those LEDs will always become warm. That's fine. Other than that, nothing is really warm. Okay. Later, Perry. So I'm going to try and disconnect the cable. Wait for a little bit, and then plug it in. No, it's instantly on. Now I blew the RS485 chip too. Sometimes things suck. Okay. So what went kaput? Okay, we need to do some measuring. Well, we don't need our safety glasses anymore. So the circuit worked once, and then it didn't anymore. Need to think here. Guess we can turn it on. Yeah, but somehow we blew an RS485 chip because the LEDs are not turning on anymore. So it's likely, yep, there we go. So there's multiple things getting warm now. One of the diodes is getting warm. Okay. And then... oh, one of the diodes over here is getting warm too. What? And the inductor is very warm. Oh, wait a minute. Okay. The DIC quad was off. Now it's on. Okay, so now the things on the board are somewhat normally hot. Oh, damn it. Okay, let's turn it on. And now all the diodes are getting very warm, and the DIC quad isn't turning on. So on the output, we're seeing what? No. Yeah, 1.2 volt on the output, because something is sucking away the power. Okay. But that only happens when the UTP cable is connected, because now it turns on. So now output power is normal. Yeah. Output power is normal. But this is a problem. The outputs are on while there's no board connected. In theory, that shouldn't be possible, right? So let's see what's going on with this MOSFET. So this has 5.3 volt on here and on here. So also on the output. Well, that shouldn't happen. Let me think. No, it's a P channel. And by default, it's pulled high. So then it should be off. Right, so then it should be... but then it shouldn't be outputting. If there's 5.3 volt on the gate of a P channel, it should be off. But it's not. So this one likely also has a high gate. Well, this one has a gate of 55 volt. Okay. Yeah, that's just because I have the wrong... okay.
They talk about another kind of word. Another kind of word.
What are you afraid of?
I'm lost in old ways.
I'm not afraid.
In theory, there's always a diode in a MOSFET. Just trying to figure out what's going on here. still, I think more is broken. Oh, wait. Yeah, because this sale of the century is now live. Okay, well, if you want to use an affiliate link, those are on the Discord or in the description. It's always very much appreciated. But in theory, the timing circuit should always delay these turning on. Especially when there's no board connected, they basically shouldn't turn on at all. Right? So that is one of these resistors. So why is it now instantly turning on? There's one pin that should be high and will get pulled low when the board is connected. And that turns on the P channel, but the P channel is already on. Let's see if we can find that pin. Yeah, so this pin is pulled high, but that P channel should only turn on when it gets pulled low. So, what I said before, no, there's no short circuit. I'm not worried about that. This P channel, I'm going to double check in my schematics. Yeah, so if we look at this P channel, so this one over here, this guy here, that's a P channel, and below is its source, so that is 5 volt or 5.3 volt, whatever, that's fine. Okay, and then the top one over here is pulled high, but once a external board is connected, it should be pulled low. But as we can see, it is pulled high. Okay, so a P channel that's pulled high shouldn't let any power through. But its output is 5.3 volt. That's not right. And so that's the reason why the RS485 chip is on. Or sorry, the 555 timer is on. Because that's also getting 5.3 volt. Okay. But even then, if it instantly turns on, the timer should still work, right? Because it needs to delay before it turns on. Doesn't matter if the P channel is high when it boots. That just means the 555 immediately gets power, but it should still do its delay, which it's not doing. So let's measure capacitance on this resistor. really? Hey, unexpected makers here. No, we already blew it up. It seems like this resistor or this capacitor might be dead. That's 22 UF, but it's measuring as 34 NF. It worked once. Is that okay? Can I ship it? No, it worked once and then it didn't anymore. So we have two problems that I can identify. The P channel has a positive voltage on its gate, but it's still letting through power. And it should only do that when the voltage is negative. Oh, okay, we're in capacitance mode. So that's a problem. And then our timing capacitor of 22 UF I know, but this cap is 22 UF, and we're measuring. Let's give it a little bit of time. Oh, come on. Oh. We're measuring in the NF range. So that's wrong. And that's also likely when I turn it on, it immediately turns on. It should never do that. There's like 0 delay, while there should be a few seconds delay. So, I mean, that makes no sense. So let's replace that capacitor, see if that fixes the delay. And if that fixes the delay, we'll replace the P channel over there. And in theory, then everything works again until it blows up. Let's see, 1206. So this is a 35 volt 2.2 UF capacitor, but it's in a 5 volt circuit. I mean, what kind of voltage is it getting that it's dying? Sorry, I need to do this slightly off screen. Okay, that should do it. I mean, that's on and off. Let me check with a magnifying glass, but yeah, that's on and off, and it shouldn't be touching anything. So yeah, we'll cool down the board a little bit, and then we'll verify that this cap is now showing the correct value. We'll use our patented flying in the wind cooling. Flapping in the breeze cooling. There. But there's going to be more problems because I think more in the board broke. No, I don't think the dig quad could be backfeeding in that sense. It's also a different circuit, so I mean, or at least behind the diode. So, okay, let's see if we can capacitance measure this new cap. Seemingly not. I don't know why. Okay, can I still find the cap I just threw away? Let's measure that one. Throw it away. No, I don't think I can find that one. Nope. Oh well. Why does it measure so low? Is my multimeter? No, it's not stuck. Okay. Measure a random other cap. It's all measuring 700 something. Why? Completely different circuit, but okay. Sure, everything is 700 NF. I don't care. Okay, let's see. Oh, can we measure these? I guess so. 300 UF. I don't think so, but okay. Hey there, Connor. Doing fine, doing fine. Let's measure this one for fun. $50. Okay, well it's 33. So who knows? Maybe it's a bit higher. Shaking the ferrets out of it. Yeah, seemingly. It's just not measuring anything. Well, okay. That's fine. Let's power it on, see what happens. So, what should happen is that these turn on with a delay. They do not. Okay. That wasn't the problem. Okay, that's fine, that's fine. So, let's assume that cap is fine. I guess we replaced the MOSFET. But then replacing the MOSFET, it's only... That MOSFET is only there to not turn on the 555 unless there's a pull down. Now, for some reason that isn't working, okay. But then the 555 should still do its timer thingy. Oh, wait, no. What could be broken is this MOSFET. Maybe the 555 is doing everything perfectly fine, but this MOSFET broke, so that immediately turns this on. Okay. DC voltage. Let me see. It should be 10 volt lower than income. Oh, what the? What the? No! The screen on my Raiden 6012, so my RD 6012 bench power supply, it has a white line on it. What the? Why? Oh no, man, hold on. Let's see, side cam. Look. It has a white light on it. That wasn't there earlier. Aw. Oh well. No, I have a white line RD6012, I guess. Well, you know, things happen, I guess. Okay. Maybe it got so stressed out by being turned on and off the whole time that it's like, hey, here's a white line. Okay. So let's see, measure this MOSFET. Yes, measure gate. Gate should be 55 volt to start with, and then go down to 45 volt after starting. Yes. Okay. I'm not sure how I'm going to measure that, but we'll see. But in theory, it's now always going to be 45, isn't it? The gate is 55 volt, but the source is also 55 volt. Then why is it on? So in theory, it's off. But it's certainly not off if you measure this side. Okay. Let's, hold on. Let's turn this, do this. Okay, now everything's borked. That's fine. Oh, wrong way around. Yeah, no. Now the 555 timer can't start because the voltage just isn't there. Because everything is now borked. But that also sustains the conclusion that the 555 timer isn't turning on at all. This MOSFET just broke. Okay. Let's try something different. Let's get a different Diff-Power board, which in theory is working, because that one we just blew up. And let's see what happens. It'll likely still output immediately, but the other part of this board not booting anymore should be gone. I hope. We'll see. Nope. Nope, still the same issue. Yeah, but it's 55 volt, but that's because of the circuit it's in. And there's a Zener diode on the gate to make it minus 10 volt, basically. But the ground level is 55, and then it becomes 45. So, if you look at the gate voltage versus source and drain, that is a minus 10 difference, and that is fine. Why, when I plug in a remote board, does the power on here suffer? Does it draw a lot of power? 0.08 amps. Okay. So that's not it. Then what is drawing the power? I am so confused. Well, no, not right now. But it doesn't really matter, because if we turn this on, the MOSFET is outputting 55 volt, while it should, in theory, always be off. Now we can measure from here to here, and we should see minus 10, but we'll see nothing, because the gate is also at 55 volt. And in theory, if the gate is at 55 volt, and the source is at 55 volt, it should be off. Right? I mean, but I can't test it with the ground applied, because as soon as I connect the board, for some reason the electronics on this board fail. But I don't know why. Okay, so I'm going to take the other board again. So we plug in here, and we plug in here. Whoa, okay, something blew. Sorry it wasn't, sorry it wasn't on screen. Something in here exploded. You probably heard it. Okay, let's turn off power for now. What the hell exploded? Oh, I see what exploded. Okay, hold on. I don't know why, but it did. Let's see here. Hold on. That LDO there, can't get it in focus. Oh, maybe it's just too close. Come on. Why aren't you focusing? Anyway, that LDO there. That doesn't look alright. Yeah, there's a piece missing. Hold on. So, this LDO over here, it's not supposed to look like that. It blew open. Okay. Yeah, board goes out with a bang. Yeah, that's for sure. Well, this is exactly the issue we're trying to prevent. It seems we're not quite there yet. But then, what happened? Where's the other screw? Oh, whatever. Need to think about this. There it is. Okay. Can we fix it? Well, I can fix the board. That's no issue. But the problem is on this board. The problem is on this board. Something, when I plugged it in, killed that board. Probably a short circuit. But then again, there is fuses up to the wazoo on this board, so how the hell is it under warranty? Yeah, I'll have to ask my part supplier. But then what the hell did that? I mean, it's an 80 volt rated PTC. We're running 55 volt through diodes. Don't understand. I mean, there's even PTCs also. There's also PTCs on this board, which feed over here. There's PTCs everywhere, so it's likely a too high voltage instead of a too high current. Okay. So then, do I need to add surge suppression? I guess even more. You tried calling the engineer. I'll make sure to note that down to do that after the stream. So, for some reason, this MOSFET is continuously open. But then, what make the other? I don't understand. So we're gonna do two things. I'm not gonna make it too late today. We're already going for 3.5 hours. I'm gonna replace the MOSFET, and I'm gonna add a capacitor here to slow down the gate, in theory. Yes. So let's get a capacitor. So I'll add 2. That should, in theory, slow down the gate a lot. Okay. And then I'll go to a 150 volt MOSFET. Shouldn't be needed, but you know. Trying to think where those are. MOSFET other, it's on the bottom. Hold on. I got it without toppling the tower. So I should have a 150 volt variant. Yes, the MOSFET is in the correct orientation. That's not a problem. Come on. This MOSFET's like, I don't want to. Now, on the previous designs where we had the MOSFET on the receiver board, it was also the MOSFETs that blew. So, okay. Okay, I need to hot air a little bit again. Let's make sure I have everything in the right orientation. Okay, let's up the temperature a little bit. There. Yeah, I know it's a bit close to the cap, but don't really have a choice right now. I should have hit it with a higher temperature. Okay, there it goes. Okay, those are good. Let me check. Come on. Yep, that'll work. Okay. Okay, we need to do our cooldown again. Can we see any physical? Well, okay, we blasted this MOSFET to oblivion anyway. Well, I'm not having a bad day. It's just not working. Yeah, this cap's probably way too warm. Yeah, the cap is 95 degrees right now. Okay. We're going into fly-by air cooling again.
All right. I'll tell you.
So we should still have the problem that the 555 timer turns on immediately again because we didn't replace that MOSFET, the other MOSFET. But in theory, the output should not turn on immediately. Yeah, there goes the farads again.
Very much alike.
Okay, let's see what we're at right now. 50 degrees. Okay. Bottom of the board. 43 degrees. A little bit more waving. So those capacitors I added, those are on the gate. And combined with the resistors that are there, in theory should, you know, charge the gate slower, so it shouldn't turn on instantly, but slowly. Or rather, slowed down. Okay. Let's see again. I'm gonna wear my my explosion-proof glasses again. Okay. Oh, yes. Are we ready? In theory, because we now fixed the MOSFET, but the 555 timer is still turning on. Let's see, is this warm? No. These should now come on after a few seconds instead of instantly. Fire extinguisher is somewhere over here. Yeah, no problem. Okay, I think it's not going to work, but we'll see. 3, 2, 1. Oh. 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 Hey. It's back to life. Well, it's still wrong. These shouldn't come on because there's no cable connected. But at least we know why the output was always on. At least this MOSFET was broken. Okay, so let's do it again. Okay, 1, 2, 3, 4, 5. There we go. Okay. 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 So that part of the circuit is fixed. That also means the 555 timer is not broken. But it does mean that this MOSFET is. Because the 555 timer shouldn't come on when there's no cable connected. So, okay, I'm going to try and replace that MOSFET too. Okay. Where's the MOSFET box? Oh, here. That is a 100 volt MOSFET. I have no idea why that would break. Where did I put it? Hold on. What? Am I confused? Hey there, de Cure Maurits. Ja, het is een beetje laat, maar dat is niet zo erg. Ik ben vaak wel laat op. Of course, now I can't find my MOSFET, so... what's going on? I had it earlier today. What? It's not an N channel, right? No. Yeah, can you see them flying? It's a bit annoying. Where did it go? Why can't I find the MOSFET? The MOSFET is gone. Did I put it back wrong? I did. Okay. I put it in the wrong box. Okay, that's fine. I mean, this is a 100 volt rated MOSFET. It doesn't do many amps, but it's only powering the 555 timer. I mean, it doesn't need to do much. It's powered off a 5 volt circuit. Why did it break? So, even though we moved everything from the sender, or from the receiver to the sender, our MOSFETs are still breaking. Might be something I need to investigate at some point. Okay. Okay. This will be one of the last things I do before I call it quits for now. This one, not really, I think. Okay. Let's up the temperature. I'm tired of this stupid slow nonsense.
Shut, but I'm trying to let you through. I know the light that's inside you will light up my world, but what if this still falls through? I let you in, our world begins. I open up, I break your heart. What if you do it first? I'll be heartbroken. If heaven's kind,
close enough.
but we'll never know until we know.
I think. Let's check it. Whoa. Yeah, well, it's not completely straight, but it's straight enough. Okay. Oh god, we need to cool everything down again. There we go. Is anyone doing anything fun after this? 5 for 5 timer, and it had an argument and the timer won. Kinda. Okay, let's see what the temperature is again. Gonna go home and go to bed. Those are kind of fun. Sometimes going to sleep is excellent. Nothing wrong with that. It's also what I'm gonna do after the stream. A little bit later, but still. Okay, we're down to about... Oh, okay, you can't see. We're down to about 50, 55 degrees. I don't know. That's fine. That's fine. We'll call it. So, what this should do is now these shouldn't turn on at all. Okay? So, in theory, these should now just stay off. Okay. Okay. That didn't work. Okay. Why? Why didn't that work? That's odd. Where is my multimeters? So, if we now check this little transistor here, it has 4.8 volt on the output. That's a weird voltage. What's this voltage? 4.9. Oh, okay, that's okay. Okay. So there's still... Why? How does that work? So, this is the gate. The gate has 5.3 volts on it. It's a P channel. What? Then why is there 4.8 volt on the output? What? Huh? Let's measure the gate of this MOSFET now. Yeah. So as I was talking about before, this gate is now 44.5 volts versus its source, which is 55 volts. So that is exactly 10 volt lower. That means that for the big P-channel MOSFET, the gate is at minus 10 volt, and thus it should turn on, which it is. It does. That's good. That's perfect. I don't think I swapped the drain and... No, but this worked the first time. The first time this worked perfectly. So I don't understand, because this P channel turns on the 5 timer, because I only want it to turn on when there's something connected. So one of the lines on here is a ground which is pulled high, but if you connect if you connect the board on the other side, it pulls it low, because then it has a better low connection, and thus the P channel should turn on. But as you can see, there is no board connected, and we measured that this line here is okay, probe's the wrong way around. Is currently high. Yes. So this is high. That means this gate is high. And that means this P channel should be off. But it's not. So we fixed one MOSFET, and if we turn off the power and turn it on again, the 5 timer works perfectly. There we go. But for some reason everything is high, but the P channel is still on. That might be a good idea there, JS. why is the P channel high? And why is it that when I plug in a receiver board, this one basically dies because it can't generate enough voltage anymore? Makes no sense. I don't think we're going to figure this out tonight. So let's take another thermal look. Well, those LEDs are warm, but that's normal because there's 55 volt on them, and then resistors and things like that. The RS485 chip is 48 degrees, that's fine. The DC-DC converter is like 48 degrees, that's fine. It's converting 55 volt down to 5 volt, so you know. The DIG quad is on, so it's powering that. 1.10 volt is being used. And maybe there's something warm over here. I wonder what that could be. No, that's just some solar, I think. Yeah. Okay. Have you checked all other components in line between power input and connector? Not sure. What do you mean? It's basically working, except it isn't. Oh, Johnny's back. Johnny, we had explosions and magic smoke. That's why I'm wearing the protective eyewear. I'm trying to think what could be wrong. I guess that's boring, but you know. Yeah, we blew a hole in an LDO. I have it here. See this LDO? It's not supposed to look like... Oh, God. It's not supposed to look like that. It's showing its legs and internals a little bit too much. So, yep. Anyway. Yeah, sadly the explosion wasn't on camera, but you can hear it. Oh, I'm gonna be tired. So the only thing I can think of is that my trigger line somehow also got 55 volt on it or something, and that blows up something. It's a bit hard to explain there, crazy old man. But basically, this MOSFET over here is in a 5-volt circuit. So this pin over here. So its source pin is its source is connected to 5-volt, and then if you pull it high to that same 5-volt, that means this gate here also becomes 5.3 volts. But then when it's connected to ground, basically the reverse happens and it's pulled down to minus 5-volt, and that turns it on. And you can check in the spec sheet what the specs of the MOSFET are. This is a BSS 123. But that's a very standard, simple little MOSFET thingy. Oh, it says here it needs about 2.5 volts, so minus 2.5 volts. But we should be at minus 5, basically. Well, it worked once. And then it blew up. Well, no, it didn't even blow up. It just broke. And now I don't understand what's not working. Because I already replaced that MOSFET. Ah. I might have just figured it out. No. Okay. I was thinking maybe the resistor that's pulling high is broken, so that it's now always pulling high and overruling the ground. But that doesn't make sense, because then it should be off. Yeah, plug it in, don't touch it. Sorry. Let's measure resistance. I'm wondering. Okay, well, the resistor I have on there is a 50K, pulling it high. And we're measuring 30, so 30K. That's okay. That's fine. Yeah. Yeah, so the MOSFET is getting pulled high. So then why is it on? I don't know. I do not understand. The socket break? No. Is my cable broken? Not really. Probably, but the problem is that does mean this 4-hour live stream now is coming to an end. Power supply making irritating noises, broken screens. Oh, what do you mean? Okay, let's turn the power supply off. I'm annoyed with you. Go away. Bad trace. Yeah, but then it shouldn't have worked once. I don't know. Well, it is something for me to figure out. Power-diff isn't going to be here anytime soon. Yeah. I didn't want to go that route, but maybe I need to add some voltage surge and other protections. But we'll see. So yeah, thanks for hanging out. I had fun. I mean, stuff doesn't work, that's okay. Sometimes it doesn't work, sometimes it does. As I showed in the beginning, the secret of today was that the AN Penta Mini is releasing very soon, and that's been working great. I've been using a few of the production boards for a few weeks now. Excellent. So yeah, I'll leave you with that. Thank you for being here and joining along on the journey of non-working prototypes. At some point, we'll have a working one, and that I can move on with development. But until that point, well, I guess it's not good enough yet. So, thanks for hanging out. I'll see you guys later. Bye-bye.